This video is going to help you fill in section number 3 of your Unit 2 Polynomials flipbook. It's section number 3, the very bottom of the bottom flap. And part of this is going to be review. We've done something like this already in your previous unit. And part of this is going to be something a little bit new that I want to introduce to you. Before we do that, I noticed something that I missed from the previous video if you want to fill this in. If you remember, we talked about this special case, a binomial times a binomial, and both binomials are the same. They have a positive sign. We call that a positive. We call this one negative. You guys can see that in this case we've got two binomials. They're identical except for one is positive and one is negative. So sometimes I'll just write that as this is the positive negative situation. Positive negative situation. Alright, let's go ahead and continue now with our radicals. So the bottom of this flap in section number 3, simplifying radicals. Hopefully you remember this, and I'm covering this because a lot of students struggle with this, and I want to keep on bringing this to your attention, how to do this, because as we move on in Integrated Math 2, you're going to need to have the skills to be able to simplify radicals. So how do we simplify a radical? Here are the steps we learned in the previous flipbook, in the previous homework assignments. Take the 24 and prime factor it. So we're going to take the number 24 and we're going to factor it. I know it's an even number, so 2 goes into 24. 2 times 12 is 24. If you're doing this in your calculator, if you know that 2 goes into 24 because it's even, in your calculator, 24 divided by 2 is 12. This one's done. That's a prime number. 12 is even, so I can divide that by 2. And I'm left with 6. 2 times 6 is 12. And then 6 can be divided by 2 again. And 6 divided by 2 is 3. 3 is now prime, and we're done with our prime factoring. And we learned in the last unit that we can now write this radical like this. Square root of 24 is exactly the same as the square root of 2 times 2 times 2 times 3. And if you multiply those out in your calculator, you'll get 24. So you can verify this is the same thing as the square root of 24. And now we learned that you are looking for numbers that can be paired together with like numbers. In class, sometimes when you prime factor, you might end up with 2, 3, 2, 2, or 3, 2, 2, 2, depending on how you begin to divide this number 24 up. When you write out your new radical, put them in number order from lowest numbers to highest numbers. That way you can easily see the pairs. We've got 2 2's here. Remember, one of them escapes. One of them escapes the radical, and one of them is removed or dies. So number 2 is eliminated, and this 2 gets out. This 2 does not have a pair to go with it, another 2 to go with it, and this 3 does not have another 3 to go with it, so they stay inside the radical. So 2 got out, and 2 and 3 stayed in. So now we're going to recombine or remultiply. 2 has nothing to combine with it, so it just stays 2, and 2 times 3 is 6, and there is our simplified radical. Let's go through this process one more time. What if we have two radicals that are multiplied together? Well, basically, if you have two radicals and they're multiplied together, these two numbers can be put together. And I'm not going to do that because if I put them together, 3 times 12 is 36. Now I could just go through and prime factor like over here, but it's actually easier just to prime factor each of these separately. So the radical 3 cannot be prime factored. 3 is a prime number. So 3, this one's done. The square root of 12, let's go ahead. You know what? I'll do that in the same color so you guys see the same method. Okay. 12, 2 goes into 12. That's prime. 12 divided by 2 is 6. 2 goes into 6. 2 is prime. 6 divided by 2 is 3. and 3 is prime, and so we are done. And so notes, let's go ahead and write our radical over again with our prime numbers. Again, since we're multiplying these two radicals together, we can just go ahead and combine all of the prime factors. So we have a 2 and a 2. There's 1, 2. There's 2 2's. There's a 3, and there's another 3. That was our first radical. Remember, class, you can't do this if this was a plus or a minus sign. You can't combine radicals this way if you're adding or subtracting, but you can if you're multiplying or dividing. All right, let's take a look and see if we have pairs, and we do. 2's can be paired up together, and the 3's can be paired up together. One of these 2's escapes. One of them is eliminated. One of these 3's escapes the radical. The other is eliminated. We end up with a 2 got out and a 3 got out. Those will be remultiplied in a moment. Oh, take a look. There are no numbers left inside the radical. So the radical goes away. If all of the numbers either escaped or got eliminated and there's nothing left, over here 2 and 3 were still in the radical. Over here there's nothing left in the radical. All we have to do then is multiply 2 times 3. And when we simplify square root of 3 times the square root of 12, we just get 6. Now take a look at it another way. I'm going to show you this if you want to put this in your notes. The square root of 3 times the square root of 12 is actually equal to the square root of 3 times 12, which if you multiply those together, you get the square root of 36. And you know that the square root of 36 is a perfect square. Square root of 36 is 6 because 6 times 6 is 36. So I'm showing you the little easier method, but I want to show you the long way because most of the time they're not going to work out so neat. You want to know how to prime factor, put them in the radical, figure out which numbers escape and which numbers are left inside the radical. Okay, now here's the new part for you. What if the number in the radical is negative? What if it's negative? Now, here's our problem, is if I asked you, what's the square root of, let's say the square root of 4, you would say, well, that's easy. Square root of 4 is 2, because 2 times 2 is 4. Well, what if I asked you what the square root of negative 4 is? Well, let's think about this. 2 times 2 is positive 4, no good. Negative 2 times negative 2 is positive 4, no good. And you can't use negative 2 times positive 2 because that's not what a square root is. A square root is what number multiplied by itself gives you the number inside the radical. So in this case, there is no logical answer. There is, in fact, if you take a square root of any negative number, there is no number multiplied by itself that will give you a negative number. Positive times positive is always positive. Negative number times a negative number is always negative. So those cannot be solved. And we're going to show you what we do with those. And this will be a topic of discussion in Integrated Math 3. And you'll find out how this actually works. But I want to introduce it to you. Here's how we solve these in this class. We use the letter I. Now when you write the letter I want you to write it cursive. See how it's got a little, kind of like a little tail on the end there? The letter I, it kind of looks like an upside down question mark. I probably didn't want to make it look that much like a question mark. It's just got a more of a curve. The letter I to represent the square root of negative 1. So we solve these problems by using the letter I, and that I actually stands for an imaginary number. We know this number doesn't actually exist in real life, so we're calling it I for an imaginary number. Now, this all seems very confusing to you probably, but let's just make sure we understand how to solve this. Number 3, what is the square root of negative 12? Now remember, class, we were able to take 12 over in question number 2 and divide it up by its prime numbers. Watch what we can do here. The square root of negative 12 is the same thing as the square root of negative 1 times 12. Hope you would agree with that, because negative 1 times 12 is negative 12, so that's the equivalent. It's the same expression. All right, and we can write it again this way. This is the square root of negative 1 times the square root of 12. Remember here in question number 2, square root of 3 times square root of 12, we can actually, because we're multiplying, we can multiply the numbers and put them both inside the same radical. Well, we can do the same thing over here. We can take it apart. Square root of negative 1 times square root of 12 is the same as square root of negative 1 times 12, which is the same as the square root of negative 12. And here's where we do our little bit of magic here. This square root of negative 1 is equal to I. So now I can write the letter I in place of that. So this answer is going to be I times the square root of 12. And we figured out over in question number 2, we see that we can prime factor 12 as 2 times 2 times 3. So this is the same as I times the square root of 2 times 2 times 3. And remember, we can pair up these two 2's. One escapes the radical, one is canceled. The 3 can't go anywhere because it doesn't have a pair. And we end up with 2 escaping, 2 being canceled. When the 2 escapes, we put that in front. Now we put our letter I to represent the square root of negative 1. And now we still have the 3 inside the radical. So this answer is actually 2I times the square root of 3. That is how we handle a negative number in a radical. Let's do number 4. One more example. Number 4, square root of negative 45. Well, we can rewrite that as, we'll just shortcut this a little bit. We can rewrite that as the square root of negative 1 times the square root of 45. Let's go ahead and prime factor 45. I can see that it ends in a 5, so I know 5 goes into 45, and 5 is prime. 45 divided by 5 is 9. 9 is divisible by 3. 9 divided by 3 is 3. Those are prime. So 45 is 3 times 3 times 5. Let's go ahead and rewrite this now. For negative 1, we're going to change that, or square root of negative 1, we're going to change that to I. So this is I times, my eyes are getting very ugly, a little bit too curvy there. Let's try that. I times the square root of 3 times 3 times 5. Looks like we have a pair of 3's. One of them is going to escape the radical. One of them is going to be canceled. When 3 makes its way out of the radical, it's going to be recombined with the I. So 3 gets out, it's going to be, instead of I, it's now 3I. And looks like we have 5 that still could not get out of the radical. So 3I times the square root of 5. And there is our simplified radical when we have a negative number inside the radical. Keep that in your head, this whole idea of I. It's going to show up when we get to quadratics. We're going to have some situations where we end up with negative square roots, and this is how we're going to handle those situations.